Central Marin really are one of the leaders, I would suggest, in terms of municipal thinking, forward-looking municipalities in terms of the wastewater treatment side, and looking at it as a cycle, and looking to opportunities where either renewable energy can be generated, and certainly where the plant can be more efficient or effective.
So I'm Peter Kistenmacher. I'm the technical services manager here. We are a municipality. We service about 100,000 population equivalents, about 10 minutes north of the Golden Gate Bridge in San Francisco. You can see our plant there on the bottom right, about 10 MGD dry weather flow, mostly residential, not a lot of industrial. And we have two anaerobic digesters where that green arrow is pointing with membrane covers, about 1 million gallons each. And that's it. We've been happily operating that way for many, many years, since 1985. About 10 years ago or so, we started taking small quantities of source separated food waste. You can see the process there on the top left. That happens at a solid waste transfer station down the road, where they're taking, restaurant waste, grocery store waste, and the like, and doing some minimal pre-processing, putting it in a truck, bringing it over to our site, and then we inject it in the digester together with our wastewater solids. So we have been doing that, like I said, almost 10 years. Things were going great. We have East Bay Mud, if you've heard of them. It's a very large utility just down the road from us that sort of pioneered a lot of this on a much larger scale. We were following them onto the 10 MGD type scale. Things were great. We're doing about 20 to 30% of our volatile solids loading in the digester on a mass basis was coming from these external feedstocks, and the rest from wastewater. We realized we had a lot of extra capacity in the digester and because population isn't growing fast here, and we wanted to put in more external feedstocks, including fats, oils, and greases, and sort of these engineered food waste slurries that came from other places in the Bay Area. But some of the consulting community and like cautioned us that other agencies had run into problems when they pushed that organic loading up to, say, beyond 30% from external feedstocks. Only having two digesters, we really cannot afford a problem because there's no redundancy for us. Most important to us is minimizing digester disruptions, and then of secondary importance is kind of optimizing how the digesters work so we make the most gas and make the most revenue. So we decided to do a pilot together with Black & Beach and actually Corolla Engineers and a few other organizations, and we said, well, that's a great opportunity to use this new sensor in the pilot and see how it overlays with all this large amount of data that we're collecting. So what you see in this chart here speaks to what we feel is potentially the predictive power of this technology. And you have a yellow line and a blue line, going back basically 2 weeks or something.
Yeah, this is like 2 weeks before.
Yeah. So you have a very regular and predictable pattern. By the way, we fed these pilots from I think it was 8 o'clock to 2 o'clock. So we fed it over a shortened period of time. And these little humps basically correlated with sort of when the food came into the digester each day, and activity picked up, and then stuff was consumed, and evening hours leveled back out. Most important to us was it was predictable and repeatable. And then what happened in this May 9-10 timeframe is the pattern obviously interrupted, as you can see from the chart. Just no more, it didn't come back down. It was completely different. At that point, all of our traditional digester health metrics, volatile acids and pH and the like, they were just still showing everything perfect, normal. So, and what we had been doing all throughout this time, though, is trying to put more organic loading in the digester. And just due to the nuances of doing a pilot like this, we have limited control over what exactly we're feeding it. And some of these fog trucks one day they might have been bringing us, 2% solids. The next day, some of the stuff had like 18% solids. So it was a huge sort of, it's like eating hamburgers one day, 6 hamburgers versus a salad the next type of thing. So, and we, just because of the nature of the sampling and stuff, we couldn't really get that information until it was already in the digester at certain times. So we think there was kind of this upsetting event that happened in this time period here. The main point is the Sentry showed us this upset several days before the traditional metrics gave us a warning. And, if you've ever operated an anaerobic digester, several day warning is just could be the difference between losing a digester or not. And in fact, we went through 2 or 3 of these events for the pilot, and the first 2 times I think we lost the digester because, to be candid, the Sentry was new to us, and we were like, well, it's showing something different, but we didn't know what it means.
but also you guys were almost intentionally trying to crash that system in the sense that you wanted to find a high-end blend.
The last couple of times we were able to, stop the feed in time or increase the mixing or make other changes that ended up not having to dump an entire digester on the pilot scale.
And what was that did you guys settle on a blend percentage that you think is most appropriate at this stage?
The main question was, can we go over 30%? Because again, there were these industry studies, I think it was LA County Sanitation or others had done it, says, well, anytime you go over 30%, bad things happen. For sure, we went up to, 60, 70%. Now, the nuance of that is, what is that 60, 70% made out of? Because we have 3 different things. We have fog, fats, oils, and greases. We have solid food waste that I showed you earlier. And then we have this engineered slurry. There are some nuances. We do not feel that comfortable going to 70% with fog, for example, because the fog is just very, very, we have no control over where it comes from, what's in the truck that day. But the 2 food wastes, for example, they're much more stable. In fact, after the pilot, we ended up installing the Sentries in the full-scale digesters in the mixing lines. This shows basically this year from September back to April and on the full-scale digester. And so you can if you're just looking at pattern, you're looking at 3 different sort of operating regimes. On the left here, a lot of up and down, pretty big band. In the center, lower absolute numbers, very small volatility. And then on the right, something kind of in between. So what that correlates to is the left-hand side, that's what was our business as usual. You can see that in a high degree of volatility in the data. Then we had, and this was not planned, we had a failure in the membrane, the Evoqua membrane cover that you saw on the earlier pictures ripped apart. So we had to take one digester out of service right there at the end of July. Out of an abundance of caution, we said, well, no more fog, no more engineered slurry, just wastewater solids and the solid food waste, because we had been taking that for almost 10 years. We're very comfortable with it. It comes from right down the road. We can, inspect our process and the like. So in the middle section there, July through August.
Remarkably stable. Whatever that waste stream you're getting, that engineered food slurry, it is remarkably consistent.
Exactly. Yeah. So that's the non-engineered slurry. That's just the we call it pre-processed, and it comes as a cake. 20% solids. Basically, again from whole restaurants that are just throwing away a whole bunch of stuff that's gone bad and the like. And it's not much. It's 6 tons a day, which is pretty small amount. And then we kind of said, because power costs are very high, like I said, and the bills were starting to pile up, and we were running our cogen engine below capacity, and the digesters appeared to be really healthy. So we said, okay, well, let's take one truck, I think it was every 3 days, of the engineered slurry in addition. So at the end of August, we started layering in the second stream, and you can see it's not as volatile as before, but it's definitely more activity and a little bit more volatility than when we didn't take it.
And then I think, and this is just to bring it up, I pulled this up from yesterday.
So this is hot off the press. Yeah, exactly. Yeah. This Tuesday, 21st. So what we decided is, because the engineered slurry was working well, digesters are happy and healthy, let's take 1 truck a day of fog as well. So we just started that last week. I think it took a couple of days because it's only 5,000 gallons into a 1,000,000-gallon tank. So it just takes some time to work itself into the signal and into the tank. But yeah, the last 2-3 days, we saw a significant change in the Sentry signal. And so, this is actually subject of a lot of discussion right now. It's like, hey, do we want to maybe not take so much fog, because we're still down on single digester. And again, we cannot afford to have that single digester go down at all. The main epiphany for me was, if we looked at our traditional digester health metrics, which is mainly volatile acids, alkalinity and like, and just because of the size of organization, the cost of sampling, staffing, and timing, we can only get sort of 1 sample a day, and some weekends even 0. If you had looked at those on this graph, it would be basically a flat line, and it would have shown us that there's no difference on these different feeding regimes. But because we have this much more, like Chris said earlier, real-time data now, we're actually kind of realizing that digesters are acting very differently depending on how we feed it, and just having so much more detailed information, is just really nice to have.
We have data and we know it's valuable and we know it tells us change and we understand those things, but what does that actually mean for the operator, and what does the operator actually do when he gets an alarm, he or she gets an alarm? So that's where we're at now with you is, okay, well, it's a high-end alarm or it's a low-end alarm. What do I actually do based on that information? And that's where we're, I think, trying to figure it out right now based on our SOP guide.